Hi everyone. So I believe everyone already understand what is weighted graph and shortest path. So today we are going to look into minimum spanning tree. So there are two methods here I'm going to teach you to identify a minimum spanning tree. So the first method is using graph to identify the minimum spanning tree, and second method, which is quite popular, we call Prim's algorithm. So there are two methods. And actually, what is minimum spanning tree? I believe everyone already know about spanning tree in previous section 3.09. So spanning tree is a subgraph of a tree. Okay, so you just want to find the minimum value, minimum distance on the weighted graph, and to make sure this is a spanning tree only. So if you look at the definition over here, spanning tree can be created from weighted graph to find the minimum distance between all vertices. So that means subgraph I can create it from the original graph to find the minimum distance. So this is known as minimum spanning tree. So this minimum spanning tree has a practical application. So such as finding the minimum length of pipes required in a water system or the minimum length of pathway required to connect buildings. So let's see some example. So let's see this example here. The map below outline where certain buildings are within a university. The vertices representing the buildings and the edges representing existing path and their distance in meter. So this is one of the, this one is the original diagram. From this original diagram, I can produce a lot of different spanning tree. So for example, alright, so I draw over here. So let's say I want to draw a spanning tree. So how you draw a spanning tree? So remember how you draw a spanning tree? You need to make sure that all the vertices remain the same positions. So as right now you can see I draw so many vertices over here. I'm just trying to make sure I have all the vertices. And when you draw the vertices, okay, after done, please label W2, W1, C, S1, and how are you going to draw the spanning tree? So remember, this is your original diagram. So you want to draw a tree. Make sure there's no multiple edges and no cycle form as well. So I have many different possible answers. Let's say I draw this way, and I connect over here. Then I choose the line come over here, and I choose this one. This one, and here, this one, this one, this one. So I connect from here. Okay. So this one is one of the example of spanning tree. But how should I make sure that my spanning tree, the spanning tree that I draw, is the minimum one? That means it should have the total, the total value over here. How I get value? That means this value over here. How should I get the total value? Keep it as minimum. So this is our objective today. So let's look at the next slide. So the maintenance team want to cover some of the parts so that the student stay dry when it's raining. So possible spanning tree could be, so these are the three possibilities. These are the two possibilities of the spanning tree. So this one is the one of the possible answer. This one is the second possible answer. Of course, I should have 3 and 4 and 5, a lot more possible spanning tree. Remember, this one is the original diagram. But how should I make sure this spanning tree and this spanning tree over here will give me total minimum value? So let's look at the second slide. So the maintenance team want to keep the cost down. So therefore, they need to find the spanning tree with the minimum distance. So this is what we know as minimum spanning tree. So this is also another sample of the spanning tree. So we can see the above spanning tree is also the minimum spanning tree, which is 2110 meter, but there's an algorithm we could use to determine the minimum spanning tree known as prim algorithm. So the question over here say that this one is the minimum spanning tree, but how I know this one is the minimum spanning tree? So I'm going to teach you using the algorithm, okay, which is prim algorithm, to find the minimum spanning tree. Alright, so let's look at the algorithm. So an algorithm is a precisely defined routine procedure that can be applied and systematically followed through a conclusion. So when the question asks you to find, okay, prim algorithm, that means indirectly it's asked you to find minimum spanning tree. So this one you need to remember. So prim algorithm means find minimum spanning tree. Minimum spanning tree also can be said I want to find using prim algorithm. Because sometimes students cannot remember, actually prim algorithm is looking for minimum spanning tree. Okay, so let's look at the algorithm over here. I will go through really fast because I will show you using an example. So step 1, please choose any vertex within the network. That means you can start at any vertex that you want. And step 2, find the edge with the lowest. Okay, this one must highlight. Find the edge with the lowest value connecting this vertex to another vertex. And number 3, look at all edges connecting these two vertices and choose the edge that has the lowest value. So the keyword over here, lowest and lowest again. That means you always look for the lowest value. And you're going to repeat this step 2, 3 again. Repeat step 2, 3 again until you finish all the vertices. So let's look at the first example. We do not delay.